2023, Chapter 10, Section 1, Goodness of Fit Test. This is Part 2. And this problem here is just, I showed you in the Part 1 how to calculate the chi-squared value based on having to do it by hand and using the chart. You will have one problem where you're on the exam where you're going to have to do that and you're going to have to show the work. This one is purely calculator. It says a researcher claims that the number of different colored candies in bags of dark chocolate M&Ms is uniformly distributed. Uniformly distributed means that they're supposed to be the same number in every bag. To test this claim, you randomly select a bag that contains 500 dark chocolate M&Ms. The results are shown in the table below. At alpha 0.1, test the researcher's claim. So here we have the observed frequencies, okay, which we're going to put into the calculator in list 1. When we come over here, because they were uniformly distributed, that means each one of the candies, if they're uniformly distributed, if we divide 500 by 6, we find out that there should be 83 1/3 of each color in the dark chocolate bag. So again, the 500 was the sample size. That's how many was in the bag. We have 6 categories, 6 colors. So if we divide 500 by 6, we get 83.33. So there's our expected values, 83.33. I just chose to put in list 2 83.3. Alright. Now remember, when we figure our chi-squared value out, if the chi-squared value is larger than the table value, then we reject the null hypothesis. Alright, so the null hypothesis is that the expected distribution of different colored candies in a bag of dark chocolate M&Ms is uniform, meaning the same. That's the claim. Alternative hypothesis, the distribution of different colored candies in bags of dark chocolate M&Ms is not uniform. In other words, at least one or more are different. Because we have 6 categories, we subtract 1, we got degrees of freedom of 5. We go to the chart. We can look at 5 degrees of freedom. Remember, it's 0.1. So if I come over here, I think you can see the chi-squared value is 9.236. I think it was 0.1. Was it 0.1? So I've written this all down here. The chi-square from the table with 5 degrees of freedom is 9.236. Again, let me show you this. Here's the degrees of freedom of 5. We followed over here to the column is 0.1. That's where I got the 9.236 from. We go to the calculator now. Now what's going to happen is I'm going to take and get out of this. Remember, list 1 is the observed values. List 2 is the expected. We got the expected values by taking the sample size of 500 and dividing by 6 categories, which is 6. That's where we get the 83.3 from. So now if I hit my stat button and I move over to test, the chi-squared goodness of fit test is way at the bottom. So if we come here, there's a proportion, there's the chi-squared test, which we won't cover. There's the chi-squared goodness of fit test. GOF, goodness of fit. If I press enter, you'll notice that the calculator is saying, okay, where's your observed values? Well, they're in list 1. Where's your expected values? They're in list 2. What's your degrees of freedom? Well, that's 5. 6 categories minus 1. That's all there is to it. We're going to come down here. We're going to hit calculate. And now we can see that our chi-squared value is 3.017. And that 3.017 is less than the 9.236 that we have. Again, I'm going to put the calculator and the value there together. So see how the chi-squared value that we calculated is less than the chi-squared value from the table. So therefore, There is not enough evidence at the 10% level of significance to reject the claim that the distribution of different colored candies in bags of dark chocolate M&Ms is uniform. So the company's claim that the colors are uniform can't be rejected because the calculated chi-square value is less than the table chi-squared value.